In the last video, we were trying to figure out what x plus h to the nth power was, and we're using the binomial expansion to just expand out what that would become. Here's an example of what it would be to the second power, but in this case it can be any power, doesn't matter. It can, and we raise it to the n means whatever. Where h is just a change in x according to our graph up here, right? The distance between some x and the next x is just a change in x, okay? So we're using that binomial expansion to expand that out, and I'm going to try to write it in a with using what I know, because I know that if I have n and I choose 0, there's only one way to do that. So I'm just going to try to write this out as best I can, and we'll see if that helps us at all. Okay, so x plus h to the n. Well, n choose 0 is just 1. There's only one way to do that. H to the 0th is just 1, so my first term is just x to the n. Great. Alright, so that's a little simpler than what I have there. My next term there, well, n choose 1, that should be a 1. I had circled it before, made it look strange. N choose 1, there's only n ways to do that. Okay, so I'm going to make this brown. I'm going to say n, and x to the n minus 1 stays the same. There's nothing I can do there. X to the n minus 1. And h will have to stay as well. So okay, so I multiply those three terms out. It looks like to me for the next couple terms I don't feel like using a combination formula to break that out. So I'm just going to leave it at n choose 2, x to the n minus 2, and I'm going to leave my h squared there. And if I keep going with that, I'm going to get all the way down to plus n actually n choose n minus 1. Well, just a brief review, n choose k is the same thing as n choose n minus k, right? So this is actually just n, right? So I could just make that n. I'm talking about this guy right here, and I could just make that n x h to the n minus 1, and then my last term is just h to the n. Okay, h to the n minus 1. Alright, so that's what x plus h to the n becomes. Now, what concerns me is I want to divide out, well actually no, first thing I want to do is I want x plus h to the n minus x to the n. Why do I want that? Well, let's look up here. On all those terms I have, right here I have x plus h to the n minus x to the n. Okay, I don't even worry about the constants right now. I'm going to deal with that in a second. But that's what I have. I have x plus h to the n minus x to the n. For every one of those terms, I'm going to have to subtract that highest power of x. So let's look at that. What would that become? Well, rewritten, I have my x to the n, right? So I have x to the n, and I'm going to subtract an x to the n. Okay? And then I have every other term that I have in there. N x to the n minus 1 times h plus that n choose 2, x to the n minus 2, h squared, plus n x to the h to the n minus 1 plus h to the n. Okay, great. So that's x plus h to the n minus x to the n. That's going to be. These guys are going to cancel out. So this is just what I'm left with, this stuff over here. Now I want to divide out my h, right? I want to divide out all my h's. So all the h powers get subtracted by 1. This first one here, this just gets erased. This h squared becomes h to the first. This h to the n becomes h to the n minus 1. This h to the n minus 1 becomes h to the n minus 2, right? And this h just goes away after I do all that. So what do I get? So I have, let me write it down here, x plus h to the n minus x to the n over h equals, this should be an h, sorry, it gets a little weird, I know, n x to the n minus 1 plus n2 x n minus 2 h plus n x h n minus 2 plus h to the n minus 1. And actually there's a bunch of terms in between here, but they all have h's in them. And what we really want to do is take the limit as h approaches 0. So basically all the terms that have h in it, I'm just going to plug a 0 in for h. And all these guys go to 0. All the h terms cancel out and they get 0. So the only thing I'm left with is this guy, n times x to the n minus 1.